Welcome, future elementary educators. This screencast is all about equations of lines. This screencast is all about how we bring algebra and geometry together through the use of coordinate geometry. Coordinate geometry was the creation of mostly Rene Descartes, who wanted a way to say, here's a picture of the algebra we know so well. And if you're like most folks, when I say equation of line, you say, oh, I know what that is. That's y equals mx plus b. I know what that is. The equation of a line is y equals mx plus b. Anything I graph that looks like y equals mx plus b gives me the equation of a line. And that's true. That's true, right? So let's pretend that you have some line. It looks like this, and it goes through maybe 0, 1, and it goes through maybe 2, 5, and so you're looking, you know that it's y equals mx plus b, and you remember that the b is the y coordinate of the y-intercept. B is the y-coordinate of the y-intercept. It's the y-coordinate of the place where the line hits the y-axis. So you're like, I got this. This is y equals mx plus 1. So now we just have to figure out what m is, and it's easy to figure out what m is because we know another point that's on the line. And we know that this point has an x coordinate and a y coordinate. So we can substitute 5 for y and 2 for x. Notice commutative property of multiplication. Commutative property of multiplication. And we can figure out what m is using all the algebra we've done before. We can subtract 1 from both sides and divide by 2. We can figure out that m is 2. And so the equation of this line is y equals 2x plus 1, right? Like this is old stuff we know from high school. Except that some of you are going to ask yourselves, what was that m anyway? What did that mean? What does that stand for? If the b is the y coordinate of the y-intercept, what's the m? And the m is the slope of the line. Well, what's slope? Well, slope by formula is a second y value minus a first y value over a second x value minus a first x value. Some of you may have seen slope written as a change in y over a change in x. Some of you may have seen slope written as a rise over a run. Slope is a way to quantify how slanted a line is. We pick a couple of points on the line and we look at how far it rises over a corresponding run. This is a delta y, it's the rise. This is a delta x, it's the run. This point is x1, y1, and this point is x2, y2. That is the basic idea. Why is slope abbreviated with m? Nobody knows. I had a conversation with one of the foremost mathematics historians on the Eastern Seaboard, and he says nobody has a good idea. The first time m shows up in any manuscript for slope, it really is the tangent of an angle that the line makes with the positive x-axis. So it doesn't even have to do with slope in that situation. It has to do with tangents, which those of us familiar with trig are going to recognize play a role here. So back on track. What if we have some line and that line passes through 0, 6 and 2, 0. Can we find the equation of that line? Sure we can. Of course we can find the equation of that line. The equation of that line is y equals mx plus b, and we know what b is, right? B is the y-coordinate of the y-intercept. That's the y-intercept because the x-axis goes across and the y-axis goes up and down. So the b value is the y value of the y-intercept, and that happens to be 6. And then the question is, what is slope? Well, slope is the second y minus the first y over the second x minus the first x. And then it's just up to us to decide which of these coordinates are the ones and which of these are the twos. So we'll let this one be the ones, and we'll let this one be the twos. So the second y minus the first y is 0 minus 6, and the second x minus the first x, that's 2 minus 0. So we get negative 6 divided by positive 2, and my middle school teacher told me that that's negative 3. So the equation of this line is y equals negative 3x plus 6. And you're like, yeah, that's all well and good, sir, but in both of your examples, you gave us the y-intercept. So what happens if you don't give us the y-intercept? Well, you ask excellent questions. Here's the point 2, 6, and this will be the point negative 1, 3. Sure. This will be the point negative 1, 3. And we want the equation of the line, and the equation of the line is y equals mx plus b, but we don't know b yet. We don't know the y-coordinate of the y-intercept, and so we ask ourselves, maybe we can find the slope first. And if we find the slope first, that's the second y minus the first y over the second x minus the first x. Careful, it's minus a negative, right? Well, the slope is 1. And if the slope is 1, then the equation of the line is y equals 1x plus b. And then it's just up to us to figure out what b is. We can do that because we know a coordinate pair. So this is an x value and that's a y value. And so we can substitute 2 for x and 6 for y, 2 for x and 6 for y, and figure out what b is. You know what b is. And so, oh, that's terrible. That's terrible. I'm not even going to declare a do-over. I'm going to let you know that I made that mistake. And I'm not proud of that, but I'm glad I caught it before the comments section. That's just, you don't want to get blown up in the comments, right? So one other thing before we're done with this. What happens if the line is horizontal, maybe with a y-intercept of 4, or what happens if the line is vertical, maybe with an x-intercept of 5? How do we find equations of horizontal and vertical lines? Well, in this case, it's pretty easy. All the points on that horizontal line have the same y value. They all have the y value of 4. This is 3, 4. This is negative 2, 4. All of the points here have the same y value, and so we say they all have the same y value. That's 4. In the blue case, similar thing. All of these points have the same x value. This is the point 5, 2. This is the point 5, negative 1. And so all of these points have the same x value. That x value is 5. And so we say all of those points satisfy x equals 5. Okay, kept it under 10 minutes. Hope this is helpful to you.